Hello. Start చేయొచ్చునా? Okay, right, thank you. Good morning, everybody. So today I'm going to start lecture on geotechnical engineering, particularly for GATE examination. You know, several engineering subjects are there in civil engineering. You can have a glance of different subjects, general aptitude and various other engineering subjects. And GATE examination is for 100 marks, out of which 15 marks for general aptitude and 18 marks for engineering mathematics and all the various different types of subjects of civil engineering. Today, I am going to deal geotechnical engineering. Geotechnical engineering is very important subject and most predominant subject from the point of view of GATE examination. Very recent year 2020 GATE, for the questions are given for 14 marks, both in paper 1 and also paper 2. So almost weightage is 14%. So in general, the questions, number of questions in geotechnical engineering varies from 10 to 15 in GATE examinations. At any cost, it will be not less than 10 marks and it may be up to 15 marks. So the predominant importance is to be given for geotechnical engineering. You know, geotechnical engineering consists of two different parts. One is soil mechanics, second one is foundation engineering. Soil mechanics is a part of civil engineering that deals with the type of soils, properties of soils, and behavior of soils, whereas foundation engineering deals with the analysis of foundation, design, construction, and maintenance of the foundation or substructure with reference to various engineering applications related to soil. So these are the two important broad classification of geotechnical engineering: soil mechanics and foundation engineering. Carl Terjagi, the father of soil mechanics, and here the very first chapter that we are dealing, origin of soils. Normally the soils will be formed from the disintegration of rocks. The disintegration of rocks by means of several means that we will see very little later, and by different means of transportation, the soils will be deposited at different levels. Accordingly, the classification of the soils derived. Let us see the formation of soils. So normally the soils will be formed formation of soil. So normally soil is unconsolidated earth material which is on the above earth surface, on the earth surface. Normally, the soil will form by disintegration of rocks into boulders, boulders into pebbles, pebbles into stones, stones into coarse material, then fine material, etc. by means of different activities. So the major disintegration of the rock for the formation of the soil or physical disintegration, chemical disintegration, and also disintegration by means of decomposition. So these are the three different disintegration of the rocks and also other materials for the formation of soil. The formation of the soil is called as pedogenesis. Pedogenesis is the process of formation of soil. And here we can look at the figure. It is the geological cycle. Geological cycle. So you can look at the figure. This assume that it is a hill, and because of several means of weathering, the formation of soil takes place, and that formation of soil will be transported from one place to the other place by means of various sources and deposited in some place, and upheaval takes place. Upheaval means rising the ground because of several forces on the earth. And again, this upheaval may be disintegrated and formation of the soil, again transportation, deposition, upheaval, etc. This is called the geological cycle. So upheaval, formation of a hill, then weathering of the rock material, transportation of the materials, deposition someplace, again upheaval, and it is called complete geological cycle. Formation of soil is by means of weathering of rocks and also geological agents. Weathering of rocks takes place by means of three means: physical weathering, chemical weathering, and biological weathering.
Students ఎవరికి లింక్ రాలేదు ఫోన్ చేస్తాం
Students
లింక్ అసలు రాలేదు ఫోన్ చేస్తాం మాకు కూడా రాలేదు
సార్ స్టూడెంట్స్ కి లింక్ పోలేదంటున్నారు సార్. సార్ మళ్ళీ బిగినింగ్ నుంచి చెప్పాలి కదా సార్. ఓకే, ఇది క్లిక్ చేస్తే పోవడం లేదు. నెక్స్ట్ స్లైడ్.
అందుకే ఇది ఇట్లా చేసేటప్పుడు ఇది వేస్తాం సార్, డ్రా చేసి ఏదైనా డ్రా చేసేటప్పుడు మౌస్
ఫోటో కనపడుతుంది.
ఫోటోస్ అసలు లింకే రాలేదు అదే ఫోన్ చేస్తాం అక్కడ సిస్టమ్
లేదు సార్, చాలా మంది ఫోన్లు చేస్తున్నారు, మెసేజ్లు పెడుతున్నారు. రైట్ నౌ బాగుంది సార్. హలో సార్, రైట్ నౌ బాగుందా? ఓకే ఓకే సార్, రైట్. ఓకే, రైట్, థ్యాంక్ యూ. So today I am dealing with the geotechnical engineering. It consists of two different parts, soil mechanics and foundation engineering. Soil mechanics deals with the types of soils, origin of soils, properties of soils to the engineering importance. Foundation engineering deals with the analysis, design, execution and construction, maintenance of the foundations of different types of structures dealing involving with the soil. And in this first topic, soil mechanics, mechanics involved, soil mechanics. So mechanics, both engineering mechanics and also hydraulics are involved in arriving or deriving the properties of soil at different stages. So soil mechanics includes the inclusion of mechanics and also hydraulics and its properties for the analysis of the soil. Formation of soils. So generally, before going for that, let us see the geological cycle. You can see the figure. This is a hill, and because of several means of disintegration of the rocks, weathering takes place and soil formed. And the formation of the soil transported from one place to the other place and deposited in some other place, and upheaval takes place at the end. Upheaval means rising of the earth surface, rising of the earth above the ground surface. And again, this rising of the earth surface is going to degrade, disintegrate by means of weathering, and again transportation, deposition, upheaval, etc. It is a continuous geological cycle. And formation of soil. Normally, the soil will be formed by means of the disintegration of large size of material to the small sizes from rock to the clay minerals. And the disintegration of rock will take place by means of several effects, and accordingly big size of rocks will be disintegrated into certain sizes. Then boulders will disintegrate to pebbles, and pebbles will disintegrate to further small size, and again further small size. Finally, it will be formed the coarse grained soil or fine grained soils. And the process of formation of soil is called pedogenesis. Formation of soils normally by means of weathering of rocks and also geological agents. Weathering of rocks can be taken place by physical weathering or otherwise mechanical weathering, chemical weathering, biological weathering. In case of physical weathering, all physical effects or mechanical effects will take place, and accordingly the rock or any other big size of the particles will disintegrate. So what are the various physical or mechanical efforts? Physical effects are temperature. Because of the changes of temperature, there is a possibility of disintegration of the rock because of involving the strain and also prevention of the strain, etc. in different directions. And abrasion. Abrasion means collision of two different particles or with the same particles. It may be while transporting the soil from one place to the other place, one particle may collide with the other particle, and because of that action, the material will be disintegrated further. And wedging action of ice. Sometimes if the cracks occur in big rocks, and in that water present, and because of the low temperature, the formation of ice may take place. And once the formation of ice takes place, the size of the ice is more than size of water, and internal forces will evolve, and accordingly the disintegration takes place. And sometimes growing the plants on the rock also disintegrate by penetrating the roots in various parts of the rock. So all these effects are physical effects, and whatever the disintegration takes place, the soil will have the same properties as that of the original rock. That's why there is no change in composition of the original rock. All particles are having the same chemical properties of the parent rock. And because of the physical weathering, the formation of the soil is either coarse grained and also non-cohesive soils. So coarse grained means the size of the particles more than 75 microns. And a non-cohesive means cohesion less soil. There is no cohesion, and cohesion value is equal to 0. And we can call it as sandy soils. All the soils formed because of the physical weathering are called the sandy soils. Chemical weathering. And because of the disintegration of the rock can also takes place by means of various chemical effects. And the different types of chemical effects are the process of oxidation. That means oxygen combines with the rock and it forms a new mineral. That process is called oxidation. Or hydration. Water penetrates into the rock and water reacts with the minerals and it forms new material and forms the soil. Carbonation. Carbon dioxide combines with the rock and reacts with the some of the minerals in the rock, and accordingly the soil will form. Soil formed due to carbonation is by means of chemical action. And the solution and leaching. Sometimes the material, the rock may consist of leached type of materials. For example, calcium carbonate contains in any rock, and due to the presence of water, it leaches. And because of the leaching of activity, the soil forms. Hydrolysis. Water particle may dissociate with H plus ions and also OH minus ions, hydrogen ions and also hydraulic ions, and because of this the soil rock will gets disintegrated and formation of the soil occurs. So these are the different types of chemical processes that the rock will disintegrate and forms particles of combination as called as clay. And because of the chemical weathering, the type of soil formed is fine grained soils, and it is having cohesive properties. Because and also the properties of the original rock will also change because of the process of the chemical action. And that's why all the soils that are formed because of the chemical weathering will have uh, cohesive properties. And we always call the soil formed because of chemical weathering is fine grained soils. The other type of weathering, biological weathering. So normally this type of weathering occurs in case of vegetation. In case of vegetation, where a lot of vegetation occurs, and that vegetation will convert into the soil by means of biological weathering. In general, in villages, agricultural waste also degrade biologically, and finally it forms manure and also different types of soils. So the examples for biological weathering is a peat, humus, and also muck. Peat is a material degraded due to biological weathering of the organic matter, and it contains all the peat also contains fibers materials. So that means agricultural waste product, if we keep at some place and after few days it will convert into peat soil, and it is a combination of material and also the fibers nature. Whereas humus, it is further decomposed material of peat. And here it is called partly decomposed material and partly organic material. And one more is muck. Muck is a fine powder that is associated with the soil and also biological material. So these are the different types of weathering activities, and normally the soils that are formed by means of biological weathering are also called cumulose soils. Sometimes the questions are very simple. The questions from this may be asked. Peat is associated with different things: biological weathering, physical weathering, chemical weathering. That may be the question. Or otherwise, cumulose soils are called. It is biological soils. Due to biological weathering, cumulose soils will be formed. So all these small and points are important from the point of view of the examination. Then second part is geological agents. So here, because of the several forces that are acting on the earth, there are two different types of agents. One is endogenous geological agents, exogenous geological agents. Endogenous geological agents, these will originate below the earth surface. That means the changes occurs below the earth surface is because of the endogenous geological agents. And because of this endogenous geological agents, it creates topographic irregularities. That is, the entire surface of the earth or part of the earth will change its topography. It is because of the volcanic eruption, earthquakes, change in groundwater, etc. And these are the various forces that are associated with the endogenous geological agents. Second one is exogenous geological agents. Soils will form above the earth surface or by means of the exogenous geological agents. By once the soil disintegrated at some place, that may be transported through river or through wind or by means of ocean, by means of glaciers, etc. All these are above the earth surface, and formation of soil above the earth surface is by means of exogenous geological agents. And here the soil is going to transport from one place to the other place, and while transporting soil from one place to the other place, because of the abrasion and also attrition action, the soil is further breakdown, and we get always the fine soil as it moves from one place to the other place. Types of soils. Based on transportation, we have seen above the surface, there are two different types of transportation. Sedimentary soils. Sedimentary soils means the soils which are formed because of the transportation, which we can also call it as transported soils. Second one is sedentary soils, or it can also be called as residual. That means the soil formed at the parent rock itself, that is called the residual soil or sedentary soil. In case of sedimentary soil, which are formed because of the transportation from one place to the other place and finally deposited in certain location. For example, the transportation by means of lakes, the soils are named as lacustrine soils. The transportation by means of rivers and streams, the soil is known as alluvial soil. By means of sea, marine soils. Transportation by means of wind, aeolian soils. By means of gravity, colluvial soils. So by means of gravity means sometimes some particles in the atmosphere may settle down because of the gravity. Such type of soils are called the colluvial soils. And also at the top of the hills, if any rock or any particle is unstable in nature and because of the gravity, it is going to move from top level of the surface to lower level. That means at the foot of the hill, at the foot of the hill, the soil obtained is called the colluvial soil, and that will be formed by means of the gravitation, and example is talus. Glacier soil. Glacier soil is formed because of the transportation of the glaciers. And a river near the ocean, sometimes what is going to happen is because of the currents in ocean, waves in ocean, currents in ocean, the soil will form near to the river outside of the ocean, that is called the estuarine soil. The estuarine soil. These soils will form soil near the estuaries. And these are the different types of examples for soils, and these soils will be seen little later in the form of soils or sedentary soils. So these are the soils formed without any transportation. Without any transportation. So at a parent rock, the soil gets disintegrated because of the chemical action. Because of the chemical action, the soil will get disintegrated and it forms at the place itself. And the examples for it will be black cotton soil, laterite soils. Black cotton soil and laterite soil are having high cohesion and low angle of internal friction. And chemical properties also change from the parent rock. So most examples, important examples for residual soils are black cotton soil, and it is normally found because of the chemical weathering without any transportation. And parent rock is basalt or trap, and it exhibit always high swelling and also high shrinkage characteristics. High swelling will take place when soil present with the water, and high shrinkage will take place when the soil is in a dry condition. When the soil is in dry condition. So these are the two extreme problems that we normally found for the construction of any type of structures over the black cotton soils. So that means in one season, rainy season particularly, the soil will swell, and in summer season where there is no water, there is no moisture in the soil, then shrinkage will takes place. So this swelling and shrinkage will takes place because of the presence of montmorillonite mineral in the black cotton soil. Black cotton soil contains large amount of montmorillonite particles. So these montmorillonite particles are very fine particles, and which are always gives high swelling and shrinkage characteristics. Second one, laterite soils. Laterite soils. It will be formed because of the leaching of the some of the minerals. It will formed because of the leaching. For example, calcium carbonate present in the rock. So because of the presence of calcium carbonate in the rock, leaching it takes place and it forms the soil, and that soil is sometimes red color or pink color in nature. That is due to the presence of iron oxide. And we can also classify the soils based on the size. Coarse grained soils and fine grained soils. These are the two different types of soils that are associated with the soil mechanics and designing various engineering structures over it. Coarse grained soils will be the size is more than 75 micron, and fine grained soils are called as soil having size less than 75 microns. And coarse grained soils will be called as gravels and also sands. And normally these gravels and sands will be formed because of the physical weathering, whereas silts and clays are called as fine grained soils, and the size of these two are very small, and this is because of the chemical weathering. And several forces acting on the soil particles. One is body force. This body force is very predominant in case of gravel or sand. There is no cohesion in this soil. All particles are independent. All particles can slide one over the other. There is no cohesion between the particles. And body force is very predominant in case of gravel and sand. And when the body force is more, body force is more, naturally the effect is also more. So body force is proportional to the mass. Surface force. Surface force is predominant in case of fine grained soils, particularly clay and particularly clay. So surface forces are more in clay, and normally the magnitude of the force is proportional to its surface area. More will be the surface area, more will be the cohesion. So when the particles sizes are very small, and when we calculate the surface area around each and every particle, the surface area of the fine grained soils are always more than that compared to coarse grained soils. So when the surface area is more and more in case of soils, the cohesion effect also predominant. And in case of silty soils, which are in between these two, cohesion and also angle of internal friction, both body force and also surface force are to be considered for the evaluating the several things. So out of formation of the soil by means of different ways, we get different types of soils. Let us have a look at the different types of varieties of soils. These are the nomenclature for various types of soils. Warwood clay. You can look at the figure warwood clay. It is alternate layers of silt and clay. And when the alternate layers of silt and clay formed, then that type of soil or deposits are called the lacustrine deposits. So warwood clay is associated with the lacustrine deposits, or warwood clay contains alternate layers of silt and clay. Then loam. Loam is a mixture of sand, silt, and also clay. When all the three sizes of the particles are available in a soil, that is called as loam. Calci. Calci is mixture of gravel, sand and clay cemented with calcium carbonate. So it is conglomerate of gravel, sand and also clay cemented with together. Because of the cementitious property, we can look at the big sizes of the particles. Then morum. Morum is a gravel mixed with red clay. You can look at the figure. The morum is red clay and gravel. Gravel means it has its own size and mixed with the red clay. Then bentonite. Normally, bentonite clay is very fine material that is obtained because of the weathering action of the volcanic action. So this is also called volcanic ash, very fine material. And in this very fine material, the major content of the mineral is Montmorillonite. And again, because of the presence of Montmorillonite material, both shrinkage and also swelling properties are extreme conditions, extreme conditions, and this type of material is always dangerous for the places where the construction activities are to be taken up. Special care has to be taken. And particularly this bentonite clay will be used for drilling operations. Sometimes when we go for drilling operation in certain soils, the soil may collapse. When the soil is going to collapse, there is no possibility of drilling. So to keep or to prevent from the collapse of the soil while drilling, the bentonite clay will be used. So that's why this bentonite clay is also called as drilling mud. Drilling mud. You can look at bentonite. So you can see the characteristics when the soil is in dry state, lot of cracks you can observe. That is because of the high shrinkage characteristics. High shrinkage characteristics. Boulder clay. Boulder means big size. So the boulder clay will be in the form of a big size. That is because of the glacier clay containing all sizes of the particle to form a clay. Sometimes we can also call it as glacier till. And because of glaciers, the boulder clay will form. Hard pan. Hard pan is a very fine material, very fine clay will be available, but it is very difficult to dig. It is very difficult to dig or penetrate or something. Excavation is also very difficult. So the examples for it will be glacial till or boulder clays. And this is called the hard pan soil, very densest in nature and cemented together with various particles. And this is having a unique property. And even when wet condition, it is also hard. So normally for the clay material, when it is in wet condition, the hardness reduces and it is easy to excavate. So even when the soil is in wet, the wet condition, the hard pan is still in hard condition only. Then losses. So this is the soil formed because of the wind. Because of the wind, yellow-brown silt or silty clay will be obtained. That is called the losses. And this exhibits cohesion in a dry condition and it will last on wet condition. So normally for a clay, cohesion property will be more when it is in wet condition. But it is different. You can look at exhibits cohesion in a dry condition. When the soil is in a dry condition, cohesion will be predominant and that will be lost when the soil is in wet condition. Marl. It's a mixture of calcareous sands or clays or loam, and these are the appropriate percentages. Then topsoil. The soil obtained over the surface of the earth is called the topsoil, and it is useful for the plant life. Fill. All man-made deposits are called the fill. Then tuff. It's a very fine particle ejected from the volcanoes and deposited by wind or water. So tuff is formed because of the volcanoes, and it is transported by means of either wind or water. Peat. Peat, humus, muck. These are the three different types of soils which are due to decomposition of some material, or decomposition of agricultural waste, or decomposition of the shrubs and also leaves. So it is highly decomposed organic matter and fibers in nature. And normally it is dark in color, and it always give bad odor. We can call it as manure prepared at the village level. And humus. It's a further disintegrated material of the peat. It consists of partly decomposed organic matter, and normally it appears dark brown color and organic amorphous earth of the soil. So it will be a fine grained soil. So after decomposition, fine grained soil will occur. That is called humus. And muck. It is further decomposed material. It contains partly fine inorganic material and also decomposed organic matter. So inorganic material means it is silt or gravel mixed with the organic matter, that is called the muck type of soil. You can look at peat, it contains fibrous material, and humus, it is decomposed organic matter partly, and muck, it is mixed with the soil and also soil, so that the combination will occur. The combination is both inorganic particles and also organics. That means once the manure is transported to the field, in the field, fine grained soils and also decomposed organic matter both mixed together, then that is called the muck. Black cotton soil, already explained earlier, parent rock is basalt and trap, so high swelling and also shrinkage characteristics because of the presence of Montmorillonite. And you can see the soil is black cotton. Tundra. It is obtained by means of mat of leaf and shrubby vegetation. Normally it occurs when a large vegetation is there. Covers clay, clumsy subsoil, and it is always occurs particularly in the frozen layers of the earth. In tundra, soil is very low in nutrients and minerals. So particularly for this type of material is not useful for the plant growth, and it always occurs in the frozen condition. Then till. It is a part of glacial till and deposited by means of the ice. And all sediments that are because of the glaciers, glacial clay will be formed. So these are the different types of soils formation. And second chapter is basic definitions and relations. And in entire soil mechanics and also foundation engineering, several topics are there dealing with the different aspects. In all the topics, the understanding of basic definitions and its properties relations between the properties required. So unless you understand this chapter clearly, it's very difficult to understand various other topics in soil mechanics and also foundation engineering. Here, I will try my level best to incorporate or to imbibe all the conceptual knowledge associated with the basic definitions and relations of the properties of the soils. And every one of you know that normally the soil composed of three different types of constituents: solids, water, air. Solids, water and air. And if we take a small piece of soil sample, we can see the solids, we can see the moisture in the form of water. We can also observe the air entrapped between the particles. So these are the three constituents normally occurred in the soil. And if we look at the volumetric manner, the solids will occupy to certain area and water occupies some area and air. So this entire soil mass is represented by means of the solids, water, air, both in the terms of volume and also in terms of the weight. That we will see little later. And normally in the phase diagram, soil is having three phase in general, but for some special cases, soil is also a two phase consists of two phase. Sometimes soil may have only water and solids, only water and solids. There is no air. In such a case, saturated soil. The soil is named as saturated. Sometimes for a complete dry soil, soil consists of both solids and also air. There is no water. When there is no water, the soil is called the dry soil. So that means for completely saturated soil, the two constituents are water and solids. For complete dry soil, the two, sometimes if the temperature in a particular area falls below 4 degrees centigrade, there is a possibility of formation of ice particles in the soil. In such a case, the four constituents are solids, ice, water and air. Four constituents. And in places where four constituents present, our analysis need to study by considering all the four. But in general, the soil is composed of three constituents or two constituents in general. We always establish the relations and also basic definitions relating to only the three constituents present in the soil. This let us see in detail the three-phase diagram. So it consists of solids, water, air. Let us see on the left side, capital V, total volume of the soil. Total volume of the soil. And volume of the solids is called Vs. Volume of the water is represented by Vw. Volume of the air represented by Va. Similarly, other side, it will be represented by means of the weights. Capital W is the total weight of the soil. And weight of the solids is Ws. Weight of water is represented by Ww. Weight of air is represented by Wa, and weight of A is always 0. There is no weight for it. So in this case, total weight of soil means weight of solids plus weight of water. Total volume of soil means volume of solids, volume of voids. Volume of voids means it consists of both water and also air. Both water and air, volume of air, volume of water, both constitute together is the volume of voids. That means between the solids, between the solid particles, the water present and also air present in the gaps or spaces. So the various spaces between the solids normally filled with water and also air. So that's why the volume of air and volume of water both will be called as volume of voids. So volume of voids will be sum of volume of air plus volume of water. And what is the total volume of soil? Total volume of soil is volume of solids, volume of water, volume of air. You can look at here all the equations given. Everything is in the form of a diagram. Once you keep this diagram in your mind, this matter, all concepts are involved in the diagram only, and no theoretical matter, no formulas, nothing. Understanding the basic diagrams are more important. From the basic diagrams only, we are going to derive various different types of relations, formulas derived for the soils. You can look at weight. Weight means weight of solids, weight of voids. Again, weight of voids means weight of voids means it is weight of water, weight of water. Weight of voids will be equal to weight of water. So all these equations are nothing. It is completely represented in the diagram. So everybody has to be able to visualize the diagram. Once if you are able to visualize the diagram, this entire page of small formulas, equations are nothing. So all of you try to keep this type of diagrams in your mind. Then two-phase diagram. So in case of two-phase diagram, solids always present. Solids always present, and here water disappears. When there is no water, this soil is called dry soil. Dry soil. And in the other soil, air disappears. That means all voids are filled with the water only. All voids are filled with water only. In such, and we call it as saturated soil. And in between these two, in between the dry soil and saturated soil, that is called the moist soil. That means a pot amount of air, pot amount of water will exist in the soil. Whereas these two are the two extreme cases. One extreme case is the soil, entire voids are filled with the air, dry soil. Another extreme case is entire voids are filled with the water, that is called the saturated soil. The previous diagram and this diagram are both one and the same. Only difference is here all the terminology related to water represent zero. All related to air in case of saturated soil it becomes zero. So you can look at for saturated soil, volume of voids is nothing but volume of water. And similarly, in case of dry soil, volume of water, volume of voids is nothing but volume of air. And similarly, in case of dry soil, total weight of the soil is weight of solids, weight of air. And weight of air is zero. That means the total weight of dry soil is nothing but the weight of the solids only. Weight of the solids only. Because air weight is zero. So total weight of the dry soil is equal to weight of the soil solids only. And in the case of saturated soil, total weight of the soil equal to weight of the solids plus weight of the water. Weight of the water. So this is called the two-phase diagram. So in the two-phase, one extreme is soil containing only solids and air. Another extreme is soil containing solids and also water. And accordingly, these parameter will change. The original diagram is the three-phase diagram. So if you just remember this diagram and if you extend this water to the top, it is completely saturated. Or otherwise, if the air is extended from top to the solid's top, then it is called the completely dry condition. So this is the only the diagram that you need to observe, and accordingly the two-phase system can be evaluated for any different types of extreme cases. Now let us see the various fundamental definitions related to the soil. Void ratio. Void ratio. Void ratio means how much of voids are present with respect to the solids. How much of voids, void ratio means how much of voids present with respect to solids. So that's why basic definition is volume of voids by volume of solids. Volume of voids by volume of solids is the void ratio. So here sometimes it's always confusion with the basic definitions. Understanding the definition is more important. Void ratio means it is what is the voids compared to the solids. What is the voids compared to solids? So volume of water to volume of solids. So you can look at here. You can look at here in this diagram. Here, imagine that the entire soil is consisting of solids only. There is no water, there is no air, there is no voids. So when volume of voids are zero, when volume of voids are zero, numerator is 0, so E value equal to 0. So E equal to 0. When there is no voids, E equal to 0. And on the other extremity, or otherwise you can look at somewhere, you can have the relation with the volumes, because voids and solids are related in terms of the volume. You can look at here, volume of voids is less than volume of solids. Solids volume is more, so volume of voids is less than volume of solids. So when numerator is less, E value is less than 1. And in the other case, both the volume of voids and volume of solids both are equal, then the void ratio is equal to 1. When these two, volume of voids and volume of solids, are equal, then void ratio equal to 1. And sometimes the soil may contains more voids, less soil. More voids, less soil. Volume of voids is more than volume of soil. So in that case, E is more than 1. And assume that a soil, imaginary soil, having no solid particles, entire volume of soil equal to 0, and it is completely voids. So when volume of solids is 0, if the denominator is 0, void ratio will become infinite. So that means the range of void ratio can be from 0 to infinite. But in general, we can call it as volume void ratio can be greater than 1. Sometimes it is an important question for any competitive examination. The range of void ratio is between 0 to 1, less than 1, greater than 1, more than 1, like that several options may be there. So it is always it can be greater than 1. It is not always greater than, it can be greater than 1, but it is always greater than 0. There is no negative value for the void ratio. it is from 0 to any value. It is not infinite, because infinite means it is not at all a soil. Imagine that it is a full glass of water. A full glass of clean water means it is completely water. There is no soil at all, and there is no question of treating this as a soil. It's only imaginary part. So that's why the range of the void ratio can be 0 to any numerical value. It may be sometimes 10, it may be 20, it may be 50, it may be 100, any finite value. So that's why in general we can write it may be greater than 1. And since it is the ratio of the same parameters, we always normally express void ratio either in terms of fraction or in terms of the percentage. So how much a percentage of void ratio compared to the solids? So in that way, we always represent here. And normally what is going to happen here in this case is, void ratio completely depend on the type of soil. There are two different types of soils. There are two different types of soils. Coarse grained soils and also fine grained soils. Already you have seen in the formation of the soils, coarse grained soils are the soils having size more than 75 micron. Fine grained soils are the soils which are having size less than 75 micron. So let us see how void ratio varies for the different types of soils. Look at the next diagram. So here let us look at a cubical array of keeping all the perfect spherical shape of the solids. And this is another shape, diagonal arrangement of the spherical grains. Imagine that all grains are spherical in nature. One arrangement is regular cubical arrangement. Another one is diagonal arrangement. And you can look at all the white spaces are the voids. All the white spaces are the voids. In the case of cubical arrangement, the voids are appearing more. Whereas in case of the same size of the grains, same type of grains arranged in the diagonal arrangement, the voids show very small area. So for the loosest state means void ratio will be maximum. Densest state means void ratio will be minimum. If the cubical arrangement or diagonal arrangement of the spherical grains, the maximum possible void ratio is 0.91. And in the case of diagonal arrangement of all spherical grains, the minimum void ratio is 0.35. So that means the arrangement of spherical grains in any manner void ratio range from 0.35 to 0.91 only. So I hope you understood. When the soil spherical grains arranged in any manner, the void ratio varies from 0.35 to 0.91. And another one is void ratio of the grains. You can look at here, these grains are more in size, whereas these grains are small in size. Let us call it as coarse grained soils. And another diagram, fine grained soils. So in these two, where the voids are more always in the fine grained soil. It's a simple example that you can remember. It's always sometimes confusing whether void ratio is more in fine grained or in coarse grained. Imagine that 1 kg of rice or 1 kg of rice is taken to the flour mill. 1 kg of rice taken for flour mill, and after flouring, the same material of 1 kg will fill the container to the maximum extent. So that means initially the volume of the rice is up to this, that is V1, and after flowing of the rice, that is formation of the fine material or formation of powder, the volume shows in the same container more. But the weight is same. Weight of the rice is same. Weight of the fine grain material is also same, but volume increases. Why volume increases? Because of the increase of the volume, the voids also increases. That is the only possibility, because weight of these two are same. Voids are more means volume is more means more voids will occur. And always remember, fine grained soils have more void ratio than coarse grained soil. And normally, when we look at between the fine grained soils, we may observe the voids. But in case of fine grained soils, we may not be able to see the voids, but lot of voids are there in between the particles, and that too, the number of particles are more, and specific surface area is also more. So fine grained particles have more void ratio than coarse grained soils. Second one, porosity. Porosity. So porosity is the representation of what is the percentage of voids in the total soil. In case of void ratio, void ratio means how much volume occupies when compared to the solids. Here comparison is with respect to the solids. Whereas in case of porosity, what is the percentage of voids in the entire soil? That means volume of voids divided by total volume of soil. Total volume of soil. So volume of voids by total volume. So this will be expressed as the percentage of voids in a given soil. The percentage of voids in a given soil is expressed in terms of the porosity. So once it is expressed as percentage, the maximum possible percentage is 100 only. So that means the porosity varies from 0 to 100%, or otherwise in fraction we can write porosity varies from 0 to 1. We can also call it as percentage of voids. Already I told you. So it's called percentage of voids. So let us look. When the soil is containing completely solids, that means voids are 0. When voids are 0, porosity also 0. You can look at. And voids may be any amount, maybe less than the solids, maybe equal to solids, maybe more than the solids. In all the cases, the porosity is less than 1 only. In all the cases, porosity is less than 1 only. And in the extreme case, where the solids are 0 and the entire soil occupies the voids, it is an imaginary. It is an imaginary one. It is simply keeping water in a glass. Keeping water in a glass. So volume of solids equal to 0 and porosity will be 1. That means 100% of voids exist. So the range of porosity is 0 to 100, or otherwise in fraction we can call it as 0 to 1. In all calculations and substitutions in various formulas, normally we go for fractional values, not in terms of the percentage. So void ratio is always compared with the solids. Void ratio is always compared with the solids, whereas porosity is always compared with the total volume. Total volume. Degree of saturation. Degree of saturation. So, but the meaning itself, don't try to understand the formula. Understand the basic definition, basic terminology. Degree of saturation. That means how much saturation is possible in a given soil. How much is saturation? So this possibility of saturation means presence of water in the soil. If the water, if there is no water, naturally saturation is zero. There is no question of saturation. So that means saturation, degree of saturation means how much percentage of water present in voids. Water present in voids only. Water present in voids only. So that's why degree of saturation means the percentage of water in the total voids. So that's why basic definition is volume of water by volume of voids. So in the voids, how much volume occupied by the water? That is the basic definition of the degree of saturation. So degree of saturation means there is a possibility of moisture in the voids. Moisture in the voids. And how much moisture present in a soil is represented by means of the degree of saturation. It is volume of water by volume of voids. And you can look at here, this is the soil. This is the soil where the entire voids are filled with air. Where the entire voids are filled with air. So in this case, when the entire voids are filled with air, the volume of water equal to zero. When the volume of water equal to zero, degree of saturation is zero. And it is called the dry condition. So for the perfect dry condition, the degree of saturation is zero. And on the other hand, this entire voids are filled with the water. All the voids are filled with the water. There is no air. That means volume of water will be equal to volume of voids. When you keep here volume of water equal to volume of voids, volume of voids by volume of voids will be equal to 1. Degree of saturation equal to 1. That means the entire voids of the soil sample or soil is filled with the water. Then that is called the fully saturated soil and fully saturated condition of the soil. And in between the dry condition and also fully saturated condition, the soil may have both air and water in voids. Both air and also water in voids. In this particular case, the degree of saturation may varies between 0 and 1. So one extreme, dry condition where the saturation is 0. Other extreme, where the condition fully saturated is degree of saturation equal to 1. And it is also be expressed as ratio, for fully saturated sample 100% or otherwise we can call it as 1. For dry soil s equal to 0 and the general range is 0 to 100% or otherwise 0 to 1. Then air content. Air content. Air content means how much of the air contained in the voids. How much air contained in the voids. In a soil sample, the possibility of inclusion of air is in the voids only. So how much is the content of air in voids? So that means basic definition is volume of air voids by volume of voids. In previous case, degree of saturation. Degree of saturation means how much how much water present in voids. Similarly, air content means how much air present in voids. So that is VA by VV into 100. It is also expressed in terms of percentage or fraction. And look at the extreme cases. Here, this is the voids, soil containing the voids. All these voids are filled with the water only. There is no air. There is no air. In this case, volume of air equal to 0. When volume of air equal to 0, AC air content will becomes equal to 0. So this is for fully saturated condition. In the previous case, for fully saturated condition, S is equal to 1. Now for fully saturated condition, AC equal to 0. And other extreme condition, all the voids are filled with the air only. All the voids are filled with air only. There is no water. When there is no water, the soil is in dry condition. And here, volume of air will be equal to volume of voids. And by keeping volume of air equal to volume of voids, it is the ratio and finally 1. So that means in one extreme case where the soil is completely saturated, AC equal to 1, and where the soil is in dry condition, another extreme condition, the air content will be equal to 1. So in earlier case, degree of saturation, for this case AC equal to 0 means S is equal to 1. And for completely dry condition, AC equal to 1 means degree of saturation equal to 0. So that means sum of the air content and also degree of saturation is equal to 1. Sum of the air content and degree of saturation equal to 1. That relation we will look into details little later. So for saturated soil 0, for dry soil 1, and in general it varies from 0 to 1. Then percentage of air voids. Percentage of air voids means how much percentage of air voids in the total volume. How much percentage of air voids, how much percentage of air voids in the total volume of the soil is called the percentage of voids. So don't try to remember the formula, try to understand the meaning of the basic basic terminology. Percentage of air voids. What is the how much percentage of air voids present in the total sample? That is the meaning. So accordingly, volume of air voids divided by total volume. VA divided by V into 100. So if for this particular case, here V means total volume, VA means volume of the air, volume of the air. Let us see the extreme case where the soil is fully saturated in condition. The entire voids are occupied by the water. Entire voids are occupied by the water. When the entire voids are occupied by the water, volume of air equal to 0. When volume of air equal to 0, substitute here Na equal to 0. Na equal to 0. So that means for fully saturated condition, Na equal to 0. And other extreme condition, where the entire voids are filled with the air only, and in this case no water present. So the condition of the soil is dry condition of the soil. For dry condition of the soil, all the voids are occupied by the air only. So in that case, volume of air equal to volume of voids. When volume of air equal to volume of voids, you can look at here. When volume of air is replaced with volume of voids, what is volume of voids by volume of total volume? Here we are going to replace VA by VB. So when VV by V, it is called the porosity. VV by V is called porosity. What is porosity? Symbol is N. That means the air content, the percentage of air voids will be equal to N. That means the range of the percent air voids varies from 0 to N. It is not 0 to 100 or the more than 100, less than 100. It is not the question. whatever the maximum value of the porosity, that is the upper limit. So percentage of air voids varies from 0 to n. You can look at here range of Na 0 to n. 0 to n. And for any other condition, moist condition, where the voids are filled partly with the water and partly with the air, the range of air content, air voids will be 0 to n. 0 to n. Then water content or moisture content. Water content or moisture content. So water, how much of water available in a given soil? How much of water available in a given soil? So normally this water content is always to be compared with the solids because when the soil is completely in a dry condition, the weight is only the solids, and the completely solid soil sample may be with a little moisture, above some moisture, saturated in condition. So completely water content or moisture content is associated with the what is the amount of water when compared to the amount of soil solids. So water content is weight of water by weight of solids. Weight of water by weight of solids. So WW by WS into 100. Already we have seen the three-phase diagram. In the three-phase diagram, what is WW, what is WS, etc. associated earlier. So here let us look at the water content. Water content. This water content is always with reference to the volume of the soil. Volume of the solids. S means solids, not soil. Volume of the WS means weight of the solids. Weight of the solids. WW means weight of the water. Weight of the water. So let us see the different extremities. One extremity is the voids of the soil are filled completely with the air. Completely with the air. There is no water or there is no moisture in this soil. When there is no moisture, WW equal to 0. Weight of water equal to 0. When the weight of water equal to 0, water content will becomes 0. That means for completely dry condition of the soil sample, water content is 0. And on the other extremity, where the solids are 0, it is an imaginary soil. It is not actually the soil because it is only water. There is no solid particles. When there is no solid particles, it is not treated as a soil. It is not treated as a soil, but it is an imaginary soil where there is no solids. It's an imaginary soil where there is no solids. Solids are equal to 0. So when solids are 0, water content will be equal to infinite. So that means water content varies from 0 to any numerical value. Any numerical value. That means W equal to 0%, small w equal to 50%, 100%, 150%, 200%, 300%, like that any numerical value of depending on the type of soil and its moisture condition. So here the water content can be greater than 100%. There is no limit. Earlier, there are some limits for some parameters, but here it can be more than 100% also. And value is always greater than 0. Always greater than 0. So these are the two extreme conditions where voids are filled with air, and another extreme condition where the entire soil sample is with the water. And one more extreme condition is all the voids are filled with the water only. In this case, there is no air. When there is no air, that is called fully saturated condition, fully saturated soil. So in case of fully saturated soil, the water content is always more than zero. It can be any value. It can be any value depending upon the weight of the water and also weight of the solids. Next, bulk density. Several densities are there depending upon the different phases of the soil. Bulk density or mass density. So the general terminology for the density is bulk density. We normally call it also unit weight, bulk unit weight or mass unit weight, or otherwise bulk density, mass density. It is generally denoted as gamma. So gamma equal to every one of us know that density is weight by volume. That means total weight of the soil divided by the total volume of the soil is nothing but the density. So here this bulk or mass density means whatever the soil that is available for that, the density is called as gamma. And some special cases are there, accordingly the different terminology associated with it. So we are not talking in the case of bulk or mass density, we are not talking about any moisture condition. It may be zero moisture, it may be fully saturated, it may be moderate in saturation. So general terminology for the density of the soil is weight of the soil divided by the volume of the soil. And everybody knows that when the soil contains three constituents, weight of soil is weight of solids plus weight of water, weight of solids, weight of water. There is no weight for the air, already I told you. And similarly, volume of the water means volume of the solids, volume of water, and also volume of the air. So weight divided by water. Here it may be sometimes WW may be 0 or VA may be 0, VW may be 0. Say some parameters may change, but this is the generalized density for the soil to be represented in any form. Bulk unit weight or mass unit weight, bulk density or mass density is weight of the soil divided by volume of the soil. Dry density. So bulk density is the general terminology of density. Now dry density means it is a particular type of soil. For a particular type of soil, the density is called dry density. And dry density means there is no water. There is no water. All the voids are filled with the air only. You can look at here. All the voids are filled with the air only. So that means the soil is in a dry condition and associated density is called the dry density. So in this particular case, wherever the terminology density, it is always weight by volume only. So dry density means dry weight. Dry weight. What is dry weight? Dry weight means here only solids. There is no weight for air, only for the solids. So that's why it is called WS, weight of the solids, or otherwise we can call it as WD, dry weight. WD, dry weight, or WS, dry weight of the solids, divided by volume of the dry soil. So volume of the dry soil includes volume of the solids and also volume of the air. In this particular case, V means Vs, volume of the solids, Va, volume of the air. Next, another density, saturated density, gamma saturated. So that means when the soil is completely saturated in nature, the associated density is called the saturated density or saturated unit weight. In this case, all the voids are filled with the water only. Water only. So weight of the soil by volume of the soil. Wherever the density, weight by volume only. But what is that weight? Weight of the solids and weight of the water. So here capital W means weight of the solids plus weight of the water. Volume of the soil means volume of the solids and also volume of the water. So even it is in completely saturated in condition. Submerged unit weight. Sometimes when the soil mass is submerged in the water, you can look at outer blue is water and this entire soil mass is kept in water. So when the soil mass is kept in water, buoyant force will be acting in the opposite direction. Buoyant force is acting opposite direction as per the Archimedes principle. The magnitude of the buoyant force is weight of the water replaced by the soil. Weight of the water replaced by the soil is called the buoyant force. So there will be some upward force because of the submergence of the soil in water. So you can look at fully submerged condition. The entire soil is kept under water. So in that case, submerged unit weight normally we designated as gamma dashed. Gamma dashed equal to weight by volume. Wherever the density terminology, it is weight by volume only. But what is the weight? Weight of the soil submerged. Weight of the submerged soil. The meaning of it will be weight of the saturated submerged soil divided by volume. You can look at weight of solid submerged divided by volume of the soil. So already I told you, since the soil is completely saturated in nature, that weight is acting vertically downward. That weight is called W saturated. Weight of saturated acting downward. Whereas the buoyant force, which is opposite in direction, upward direction is acting. That is weight of the water displaced by the soil. What is weight of the water displaced by the soil? The soil occupied by this volume. Volume. What is the displaced weight of water? Displaced weight of water and also soil are having the same volume. So that's why displaced weight of water is volume of the soil multiplied by gamma W. So that means in place of this entire soil, if the water is filled completely, what is the weight of this water? Weight of this water will be equal to volume of water multiplied by density of water. So that means two different forces. Weight of solids submerged. Weight of solids submerged. So one downward force acting in the downward direction, saturated weight of the soil, and upward force, buoyant force. Buoyant force is equal to weight of the water displaced by the soil. That is V into gamma W by V. And you know that W sat by V, it is called saturated density. Saturated density. And V gets cancelled gamma W. So that means submerged unit weight equal to saturated unit weight minus gamma W. So always when the soil is kept under water, fully submerged, the weight reduced. So gamma dash equal to gamma saturated minus gamma W. And here the Archimedes principle involved in the buoyant force. Buoyant force will be equal to V multiplied by gamma W, which is called the weight of water replaced by the soil. Then unit weight of soil solids. Unit weight of soil solids. That means in previous any of the cases, for example, Saturated density means density of the entire soil, density of the entire soil. So it consists of both water and also solids. So the density of this means total weight divided by total volume. That is called the saturated unit weight or saturated density, both the constituents present. Whereas in the case of density of solids or unit weight of solids, gamma S, gamma density S means solids. It is only for the solids. Only for the solids means weight of the solids divided by volume of the solids. There is no water, there is no air. There is no water, there is no air. Entire volume occupied by the solids only. So gamma S means weight of solids by weight of volume of solids. Ws by Vs. Sometimes we can call Ws or Wd, both are same. Wd means dry weight of the soil. Dry weight of the soil. Okay. And for particularly for this unit weight of soil solids, it is always constant for a given soil. Always constant. Gamma S is always constant for a given soil. Whereas gamma D is not constant, gamma saturated is not constant, gamma dashed also not constant, because that depends on the presence of voids, how much water, how much moisture occupied in the voids, how much air occupied in the voids, etc. So that's why out of all these densities, gamma S is constant because it is for a particular solid material, and the entire solid will be assumed to be filled in the soil mass. So gamma S is constant, whereas all other densities are not constant. It varies depending upon the void content and presence of void, air and also water. Now we have seen several unit weights. The unit weight of solids, saturated unit weight, bulk unit weight, dry unit weight, submerged unit weight. So you can call it as density of solids, density of saturated soil, density, bulk density, dry density, submerged density. So these are the various densities that we have seen. If we compute all these parameters, so gamma S is always more, because while computing the gamma S, here we are not, all the terms are related to the solids only, and solids are having more density when compared to air and also water. So gamma S value is always more than gamma saturated. Here gamma saturated means all the entire voids are filled with the water, because water weight is more than the air, because air weight is 0. When all the voids are filled with the water, then the weight will be more and saturated density is always more. And then bulk density. Bulk density means it is containing some part of water and some parts of air, both air and water present in bulk density. Whereas dry density, entire voids are filled with the air only, and here absence of water, it will be least. And gamma dash already you know, because of the buoyancy effect, the value of the density will become much less. So this numerically for a given soil, this is the order for the numerical value of the density. Gamma S is the highest and gamma dash will be the least. Then specific gravity. Specific gravity. Specific gravity for a material or for a water. For a material or water. And everybody knows that specific gravity of water will be equal to 1 gram per cc or 10 kilonewton per meter cube, or generally it is 9.81 kilonewton per meter cube. It will be taken approximately 10 kilonewton per meter cube. So unless otherwise given the value of 10 kilonewton per meter cube, it is always better to use 9.81 for any of the calculations. And in general, density of water is 1000 kg per meter cube. That we can in terms of tons, 1 ton per meter cube, or in kilonewtons. These are the various terminologies, units that we use for the water in different subjects of civil engineering. Now, specific gravity. Specific gravity means unit weight of soil solids divided by unit weight of water. Unit weight of water. So, the physical meaning of it will be if for a given volume, assume that it is a given volume. Assume that it is a given volume. For a given volume, the entire soil solids filled with the given volume, and find out the weight of it. Similarly, for in the same volume, the entire water is filled. So the ratio of weight of the solids to the weight of water for the same volume is nothing but the specific gravity. Specific gravity is ratio of weight of the solids to the weight of water of the same volume. Weight of water of the same volume. Just I will tell you, the specific gravity is defined as ratio of the weight of soil solids to the weight of water occupied in the same volume. Occupied in the same volume. Or otherwise, because volume is same, when volume is same, we can call it as ratio of weight by weight. That means weight of solids by weight of water, or otherwise density of solids by density of water. So I'll read here. It is the ratio of weight of a given volume of solids at a given temperature to the weight of an equal volume of distilled water at that temperature. That means volume will be the same, and it is to be measured at the standard temperature of 27 degrees centigrade, and the ratio of the weight of solids to the weight of water of the same volume, or otherwise unit weight of soil solids gamma S. It is gamma S. Gamma S means just now you have seen this. Gamma S means WS by VS. So unit weight of soil solids divided by unit weight of water. And normally G is always constant, because for a given soil particle, the unit weight is always same and it remains constant. Generally, depending upon the different types and formation of soils, G value in general ranging from 2.6 to 2.85. It may be sometimes less than this, more than that also, depending upon the other different types of soils. But for all engineering soils, it varies from 2.6 to 2.85. Apparent or mass or bulk specific gravity. So in previous case, specific gravity means it is only for the complete soil solids. There is no void. That means there is no air, there is no water. Completely for the solids. Whereas in case of another specific gravity, which we call it as bulk specific gravity, or mass specific gravity, or apparent specific gravity. So these are designated as GM. Apparent mass or bulk means whatever the soil that is available, what is the specific gravity of the soil as it is. That means in this case, the specific, while calculating the specific gravity, we are going to consider all the solids, all the air, and all the water, entire water. Here we are going to consider solids, water, and air. Whereas in the previous case, specific gravity of soil solids means we are going to see only the solids. Whereas here mass or bulk or apparent means whatever the soil sample that exists, and in that soil it always containing three constituents, solids, water and air, and for that find out the specific gravity. So for that, mass or bulk unit weight of soil divided by unit weight of water. So in earlier definition, it is gamma S by gamma W. Gamma S means soil solids, only for the solids. Here gamma means it may be any density, generalized density. It may be sometimes gamma D, it may be gamma, it may be gamma saturated also. Or whatever the soil sample that is available, for that soil sample, if you determine the specific gravity, that is called bulk specific gravity. And mass specific gravity in saturated condition. When the soil is in saturated, this gamma is going to become gamma saturated. So gamma saturated by gamma W is called the mass specific gravity in saturated condition. And sometimes when the soil is in a dry condition, gamma will becomes gamma D, dry density. So ratio of dry density to ratio of dry density to density of water will be the mass specific gravity in dry condition. And GM is not constant. Why it is not constant? Because of the presence of moisture in the soil, gamma varies. When the gamma varies, GM also varies. So that's why the mass specific gravity is always varying depending upon the presence of moisture content in the soil. Whereas G is always for the soil solids, it is always constant, and numerical value, the specific gravity of soil solids is always more than mass specific gravity of the soil. So in general, a small example to understand the concept of specific gravity of soil solids and also bulk specific gravity. Everybody knows that density of cement 3150 kg per meter cube. 3150 kg per meter cube. And its specific gravity is 3.15. Its specific gravity means it is 3.15 times more than the weight of water. That's the meaning. 3.15 times more weight than the water is called the specific gravity of the cement. That is, if we consider only the solid particles into account. But if we look at the cement, it appears to be particles are very closely spaced, but the voids are very large because it is very fine material, and in very fine material the voids are more, and in general if the cement is filled in 1 cubic meter, the weight is approximately 1440 kg. Weight is approximately 1440 kg because the majority of the area occupied by the air voids. Occupied by the air voids. Actually, 3.15 means 3150 kg per meter cubed. That means if there is no void, it must be 3150 kg for 1 cubic meter. But actually, because of the presence of voids in the cement, 1 cubic meter occupies only 1440 kg. So what is the mass specific gravity? Mass specific gravity GM is this is the weight of the cement. Weight of the cement or unit weight by unit weight of water. Water unit weight is 1000. So 1.44. What is the original specific gravity of cement? Original specific gravity of cement will be 3.15. So this is how it will be changed. So because of the presence of air in the cement particles, the apparent or mass or actual specific gravity of the cement as a whole is 1.44, whereas specific gravity for the cement particles is 3.15. So that's why specific gravity of the particles is always more than specific gravity of the total mass. Total mass. So these are the basic definitions that we have seen now for various for getting the relations and also defining the soils. Now let us see the establishing the relationships. So normally it is very simple that if I tell just please remember n equal to this, e equal to this, and if there is any numerical problem substitute and get the answer, that I can tell. But it is a fundamental subject, and always understanding the concepts will always keep you high in level for analysis, also understanding capacity, and also for problem solving capacity. So not simply by hearting all the different formulas, you may not reproduce the same in the examination. So that's why understanding the concept is more important, and I'm not going to take much time. I will explain it very in a short period of time. So you know the relation between N and E. You know E wide ratio, N porosity, and these are the basic definitions. From this, it is conventional calculation. And anyway, this presentation I am going to give it to JNTU officials, and they are going to keep it in website. You can also download and you can read it later as it is, so that you can get total information of the entire class. Okay, this is the conventional way of doing the relations. You know, finally 1 by n equal to e plus 1 by e, so n equal to e by 1 plus e. And accordingly, you can calculate e equal to n by 1 minus n, and these are the relations normally we need to remember. But it's not by means of by hearting. Automatically your mind should accept to keep all these simple formulas in your mind, like the quadratic equation. Every one of us know simply ax square plus bx plus c equal to 0 is a quadratic equation. There is no by hearting for such a type of formula. Like that, here also any formula encounters in the subject, always try to understand and try to keep the same in your memory, not by means of by hearting. So you know that this relation I am going to explain in the form of a three-phase diagram. Three-phase diagram. You know, everybody knows that basic principle. E will be equal to volume of voids by volume of solids. So when volume of solids equal to 1, when denominator equal to 1, when we assume that Vs equal to 1, what is E? E will be equal to Vv. When Vs equal to 1, what is E? E is nothing but volume of voids. So that we can represent here. You can look at here Vs. In the three-phase diagram, I will show you once. Vs volume of the solids, and Vv volume of the voids. So when Vs is equal to 1, you can look at here, Vs is equal to 1. When Vs equal to 1, what is Vv? Vv is nothing but E. You can see Vv is nothing but E. And what is the total volume? Total volume is nothing but 1 plus E. So it is 1 plus E. 1 plus E. So from this relation, what is porosity? You know, porosity is volume of voids by total volume. What is volume of voids? Volume of voids is nothing but E now. What is volume of voids? E. Volume of voids is E. What is the total volume? Capital V means total volume. Total volume is nothing but 1 plus E. So you can look at the final formula. Porosity will be equal to E by 1 plus E without any derivation. So this type of equations can be obtained or getting the relation only with the basic conceptual things. You need not by heart this entire thing. You need not to go for the derivation. It is only conventional derivation that you have seen always earlier. But if you look at and understand the concept of a three-phase system, you can get simply this relation. Similarly, let us see this three-phase, volume of solids, volume of voids, and go for the definition of the porosity. Porosity definition is volume of voids by total volume. When the total volume is equal to 1, capital V equal to 1, you can see here total volume is equal to 1, total volume equal to 1. What is volume of voids? It is nothing but N. Volume of voids equal to N. So volume of voids will be equal to N. N. When it is N, what is the volume of solids? Volume of the solids will be nothing but 1 minus N. It is 1 minus N. So that means we are incorporating the basic definition of the porosity in the three-phase diagram. Now, what is void ratio? Void ratio is nothing but, the definition, volume of voids. What is volume of voids? N. Volume of voids is N. So you can see N. What is volume of solids? Volume of solids is nothing but 1 minus N. So you can look at 1 minus N. So that means sometimes it is always confusing whether it is E by 1 plus E or it is E by 1 minus E. Similarly, whether it is N by 1 plus N, whether it is 1 by N by 1 minus N. So these are the normal confusion that any student will face at the time of examination. So to overcome such a thing, conceptual understanding is always important. So ultimately, these are the two relations. Now let us see NA. AC means air content, NA percent air voids, the degree of saturation. And all the three definitions, AC, NA and also N, already discussed earlier. Now this is the conventional way of deriving this, and you can see this later. No need of explaining all these things. So now look at this three-phase diagram. Out of all these three, I'm sorry, this is not N. Okay. Out of all these three, you can look at here volume of voids. Okay, here you can see the AC. AC will be equal to volume of air by volume of voids. When volume of voids equal to 1, you can see volume of voids means this one. This is 1. Volume of voids equal to 1. What is volume of air? Volume of air is nothing but AC. You can see volume of air is nothing but AC. Volume of air is nothing but AC. And once it is AC. Similarly, what is the degree of saturation? What is the degree of saturation? It is not given. Degree of saturation means volume of water divided by volume of voids. It is not given here. I am telling. You can look at S means volume of water by volume of voids. When volume of voids equal to 1, you can see volume of voids equal to 1. Volume of water is nothing but S. So volume of water is nothing but S. So from this you can observe the relation AC plus S will be equal to 1. You can see AC plus S equal to 1. That means air content will be equal to 1 minus degree of saturation, or sum of the air content and degree of saturation is always equal to 1. So to get this derivation, we are observing these number of steps. This number of steps not required. Now it is very simple concept that volume of voids will be taken as 1, and accordingly volume of air will be AC and volume of water will becomes S, and from this you can get the relation between air content S and also 1, and this is the relation. And similarly in the other one, you know that Na, N. So both of these two are having denominator same, VV. Both of these two are having same denominator. When these two are having same denominator, assume that V is equal to 1. Assume that V is equal to 1. So you can look at here. Assume that V is equal to 1. When V is equal to 1, what is volume of air? Volume of air is nothing but Na. Volume of air is Na. And volume of voids is nothing but N. You can see volume of voids is N. Volume of voids means the total water and also air. It is nothing but N. Now from this, AC basic definition, VA by VV. VA by VV. What is VA? VA is nothing but NA. NA. What is VV? VV is nothing but N. N. That means NA is equal to N into AC. So this is one relation between air content, porosity, and percent air voids. So relation between Na, AC, S, and N. The two important relations you arrived here. One is Na is equal to N into AC. Another relation is AC plus S is equal to 1. So this entire derivation is not required. If you want this entire derivation, some prerequisite procedure, all those things are required. But whereas here, you need not require any of the pre-calculations, simply understanding the concept of the three-phase diagram. But anyway, you have to remember the formulas automatically, not by hearting. Automatically, you need to remember, and while remembering these formulas, your mind should go to these diagrams. Then only it is very easy to get such type of relations anytime in the examination. Number 3. A relation between degree of saturation, water content, specific gravity, and E. First, basic definitions of these are required. S means volume of water by volume of voids, water content, weight of water by weight of solids, and E, volume of voids by volume of solids, G, gamma S by gamma W. Already we have seen all these basic definitions, and it is some procedure for evaluating the relation between all these. Okay, so now here let us look at let us look at E. Now let us look at E. Vs is equal to 1. When Vs equal to 1, volume of the solids equal to 1. What is volume of voids? It is E. You can see volume of the voids equal to E. Okay. Now come to the degree of saturation. Or VW. What is VW? VW means S multiplied by VV. S multiplied by VV. VW means volume of water. What is VV? Volume of voids is nothing but E. So volume of voids is E. So volume of water means this is E multiplied by S. So that's why volume of water is nothing but S into E. Similarly, on the other side, weight of water. What is weight of water? Weight of water means volume of water into density of water. Volume of density of water gamma W. Volume of water is nothing but S into E. S into E. Similarly, weight of solids. Weight of solids means density of solids multiplied by volume of solids. This volume of solids is nothing but 1. So it is gamma S. So another basic definition W equal to weight of water by weight of solids. What is weight of water? Gamma W S into E. Gamma W S into E. And what is weight of solids? Gamma S. And with these two, gamma S is again G into gamma W. Gamma S means G into gamma W. So cancel some of the things, you will get SE by G. And everybody knows that from this S is equal to WG by E. So in normal case, everybody has to remember this formula. but understand the concept in one way or the other way so that it is easy at any time. Okay, so the S is equal to Wg by E is the formula. Once S means degree of saturation. When the degree of saturation equal to 1 for saturated condition, degree of saturated condition S is equal to 1. When S is equal to 1, E will be equal to W into G. So when S is equal to 1, moisture content will be saturated moisture content. So relation between gamma, G, S, E. So in all these, if you remember this equation, it is sufficient. Gamma equal to G plus SE by 1 plus E gamma W. It's an important relation to be remembered. And anyway, I am giving this entire material to you. You can look at later, and the derivation is not of that much important. For all the different densities, gamma bulk equal to G plus SE by 1 plus E. So here if you want saturated density, S will become 1. For saturated soil, S equal to 1. If you keep S equal to 1, saturated density will be G plus E by 1 plus E gamma W. This is the base formula. And similarly for the dry soil, degree of saturation is 0. If for the dry soil degree of saturation 0 means it is this term goes to 0. So G gamma W by 1 plus E. So gamma saturated, gamma D, bulk density are known. Next gamma, the same formula, split it into two components. First component and also second component. And first component G gamma W by 1 plus E is nothing but gamma D. And this component can be written in this form so that G gamma W gets cancelled and SE gamma W will be remaining, and accordingly this is nothing but gamma saturated and it is nothing but gamma D. So ultimately if you want you can remember, otherwise not required this also. Bulk density equal to dry density plus degree of saturation into saturated unit weight minus dry unit weight of the soil. So in all these, this relation is most important. From this, you will get all the different types of densities. Gamma equal to G plus SE by 1 plus E into gamma W. I am skipping this. I am not explaining the same thing, the same concept to be used. Okay. Anyway, already the figure is same as that of the previous one. Weight of the water and also weight of the solids. You can see general weight density equal to W by V. W means weight of the solids, weight of water. Volume means total volume. What is the total volume here? Total volume is nothing but 1 plus E. You can see total volume is nothing but 1 plus E. And weight of WS means gamma S. WW means gamma W S into E. Substitute it and simplify it, you will get G plus SE by 1 plus E gamma W. So instead of derivation conventionally, you can derive the equation very simple using the three-phase diagram, and this is the most important formula to get different densities of the soils. And this is relation between gamma saturated, gamma W and gamma dashed. So it is already we have seen earlier, gamma dash will be equal to gamma sat minus gamma W. Earlier in the derivation of the conceptual meaning of the different densities, we have seen submerged density equal to gamma saturated minus gamma W. So now it is not required. Okay. Then relation between gamma, gamma D, W. Gamma D, W. That means relation between dry density and also bulk density in terms of water. In terms of water. When there is no water content, the density is called the dry density. When the soil is containing water, the density is called the bulk density. And depending upon the content of water, bulk density changes. Bulk density changes. You can also look at here. You can also look at here. This is the three-phase diagram. Assume that solids weight is 1 and water is W, because what is the basic definition of water content? Water content is weight of water to the weight of solids. Weight of water to the solids. You know that W is weight of water to the weight of solids. When weight of the solids is assumed to be 1, weight of water is nothing but W. Weight of water is nothing but W. So from this three-phase diagram, you can observe this solids, Ws is the solids, weight of the solids, divided by 1. Divided by 1 will be equal to total weight. What is the total weight? Total weight means weight of solids, weight of water is the total weight divided by the total volume. 1 plus W. So it is 1 plus W. So from this equation, weight of solids equal to total weight by 1 plus W. And you know that for these two things, if you divide it by volume, Ws by V, you can write this equation W equal to Ws into 1 plus W. So divide both sides by V. W by V is nothing but gamma. Ws by V is nothing but gamma D. So this is the relation between the two. Gamma equal to gamma D into 1 plus W, or otherwise gamma D equal to gamma by 1 plus W. So that means as the water content increases in the soil, the bulk density increases. Then relation between specific gravity, mass specific gravity, degree of saturation, and void ratio. So here mass specific gravity means gamma by gamma W. Gamma by gamma W. Already you know that gamma is G plus SE by 1 plus E into gamma W. And that gamma W, this gamma W cancel and this will be obtained. So this is derived from the previous one. You can look at here, gamma is nothing but G plus SE by 1 plus E gamma W. And basing on this, we are taking this formula directly and calculating the mass specific gravity of the soil. So gamma by gamma W is this equation. And if you cross multiply, and ultimately you will get E equal to this. But no need of remembering several formulas. Once you understood the concept of it, and after substitution of the numerical values, you can find out the any unknown parameter. Don't try to by heart E equal to G minus dot D minus this, not required. Not required. Don't try to remember such type of formulas. These are not at all the formulas. These are derived from the known equations. And when for dry condition S equal to 0. So this is a mass specific gravity. When S is equal to 0, it is a dry condition G by 1 plus E. Similarly, for saturated condition S equal to 1, put S equal to 1, G plus E by 1 plus E. And this is another formula which is used in compaction chapter. There we'll discuss much. And water content already discussed, W equal to weight of water divided by weight of solids. Moisture weight of the soil divided moist weight of soil by not moist. It is a dry weight of soil divided by weight of soil solids. Another relationship between the volume of the soil and void ratio. Normally what is going to happen is depending on the void ratio, voids present in the soil sample, volume also changes accordingly. This is the three-phase diagram, and void ratio E is equal to volume of voids by volume of solids. Void ratio is volume of voids by volume of solids. When volume of solids equal to 1, volume of voids will become E. It is the basic definition of the void ratio. So by keeping this in mind, what is the total volume now? Total volume is nothing but 1 plus E. You can see total volume equal to 1 plus E. That means volume always depends on the void ratio. Volume always depends on the void ratio. So when void depends on the void ratio, we can look at, imagine that it is a borrow pit. It is having volume 1, that means V1 volume of soil is taken out, and soil containing a void ratio 1, its existing density is gamma D1, Ws is the weight of the solids. So the soil is soil borrowed from this pit will be taken and filled at the embankment. That means whatever the soil that we are transporting from borrow pit to the embankment is the same type of soil. Soil type is same, but because of the changing void ratio, volume changes, what V2, and void ratio changes from E1 to E2. Density also changes from gamma D1 to gamma D2, but Ws is same. Whatever the solids, whatever the solids in soil transported to the embankment will remains same. There is no change in the solids content. Solids will remain same, but all the remaining three parameters will change. So assume that it is 1 and it is 2. So ratio of V1 by V2 equal to 1 plus E1 by 1 plus E2. That means when you know the volume of the embankment, when you know the volume of the embankment, and when you know the degree of compaction E2, and when you know the void ratio of E1, how much volume of the soil is to be taken from the pit. How to calculate the value of V1? So that can be done by means of this particular formula. Or out of all these four unknown parameters, V1, E1, V2, E2, if any of the three parameters are known, we can find out the other parameter. Okay, other parameter. Similarly, Vs by 1, you can see here, this is called volume of solids. Volume of solids is representing 1. Volume of solids is representing 1. And total volume is representing 1 plus E. Total volume is representing 1 plus E. So Vs by 1 equal to V by 1 plus E. So from this is another relation for calculating the volume of the solids. Volume of the solids will be equal to total volume by 1 plus E, because solids will always be same, but this volume, overall volume will change depending on the void ratio. If more will be the void ratio, more will be the volume, but Vs is same. Volume of the solids will be the same. Volume of the solids and weight of the solids does not change due to change of void ratio. And also we know that density, dry density equal to dry weight of the soil. Ws means weight of the solids. Weight of the solids. Dry weight divided by volume. So in this case, already I told you, in any of the cases, solids, weight of the soil solids remains same. So Ws is same. So dry density always depends on the inversely proportional to volume. Dry density is always depends on the V. And relation between these two, dry density is inversely proportional to the volume of the soil mass. So when gamma D is inversely proportional, we can also relate to the volume. V1 by V2 equal to, already you know, 1 plus E1 by 1 plus E2, which is also equal to gamma D2 by gamma D1. So here gamma D2, gamma D1. So V1, E1, gamma D1 are the variables. V2, E2 and gamma D2 are the variables in embankment, but weight of the soil solids remains the same, and accordingly we can find out how much quantity of soil is to be transported, or what is the volume wide ratio achieved, how much wide ratio is to be achieved by adding some amount of material, etc., using by this particular relation. It is also useful in compaction chapter. So with this, the entire theory is over. Let us spend some amount of time for the numerical questions. Let us let us spend some time for numerical questions. I'll take another 15 minutes up to 1 o'clock, so that we can cover some of the numerical questions in this. So, origin of soils, previous gate questions, and also general possible questions. Soil transported by wind are known as. It is called iolin soils. Already in the theory, it is clearly given. You can look at that. And sometimes the questions may be in the form of a matching. Lacustrine soils, alluvial soils, iolin soils, marine soils, and what is the mode of the transportation? It's a mode of the transportation. So you know that this entire theory already covered. Lacustrine soils occurs in the bottom of the lakes because of the transportation of the lakes, and alluvial soil by means of the running water in rivers and also streams. Ionian soils by means of the wind. Marine soils because of the seawater. In that case, you can match all the appropriate things. Another question, lacustrine soils are deposited in lake beds. So though everything is known to everybody, sometimes while answering the questions, it may be always some sort of difficulty unless you understood the full concept of the subject. So another matching, so loess, peat, alluvial soil, marl. So what is the origin and how it is gets deposited? You know that loess by means of the wind, peat is organic soil, alluvial soils are by means of running water, rivers, and also in streams, and marl is by means of marine origin. It is in offshore structures. Collapsible soil is associated with loss. Already I told you it is very strong when the soil is in dry condition, and it is extremely weak when it is with the wet condition. Collapsible soils losses. Collapsible means the property will change abnormally. And very recently get 2020 question, it is for 1 mark. Soil deposit formed due to transportation by wind is termed as iolin soil. So while studying the any subject, anywhere, any paper, any question, don't close only after knowing the answer. You should also look at different options also. Iolin deposit Iolin deposit, by means of the wind. Alluvial, by means of river and also stream. Estuarian deposit is by means of the currents of the ocean at the junction of the ocean and the river. And lacustrine deposits are at the lakes. So not only the answer, you have to look others also, because sometimes next time the question may be related to the other options. So these are the general type of questions from the first chapter, and numerical questions. Numerical questions. Okay, let us see. A soil sample has volume 1000 meter cubed. V equal to 1000 meter cube, 1000 meter cube, not centimeter, 1000 centimeter cube. It's not centimeters, plus centimeter cubed. And weight 196 grams. W equal to 196 grams. Got reduced to 164 grams after drying. So that means the dry weight of the soil equal to 164 grams. If the specific gravity of the soil is 2.7, G equal to 2.7, what is the void ratio? So the void ratio, what is the void ratio? So for this, you always try to recollect the several formulas that are known to you. You know, gamma D equal to G gamma W by 1 plus E. So this is the formula related with the E and some of the known parameters. What are the known parameters? Already G directly known. Gamma W is also known. It is density of the water. So G is known, gamma W is known, E is to be found, and gamma D to be found indirectly. So dry density gamma D is dry weight by volume. Dry weight by volume, it is 1.64. So one substitute in the formula and get the void ratio. So what you do is you write all these parameters and see the relation, which type of relation relates various parameters. So in this formula, if you just understood gamma D equal to G gamma W by 1 plus E, you can find out the unknown parameter. So second problem, a soil sample of weight 156 grams, W 156 grams, and 80 centimeter cubed volume, V equal to 80 centimeters cube, is reduced to 130 grams, 132 grams, it's mistake, 132 grams on oven drying. It is called WD or otherwise WS, dry weight of the soil or weight of the soil solids. If the specific gravity of the sample is 2.64, the degree of saturation is S. What is the S value? So by knowing all these parameters, immediately observe the appropriate relation. Everybody knows that S equal to WG by E. The S equal to WG by E. When you know the S equal to W by G, you can find out all other, by knowing all other parameters, you can find out S. What is W? What is W? W equal to water content. Water content means weight of water by weight of solids. So you can look at here, this is the original weight of the sample 156. It is dry weight. Difference of these two is called the weight of water divided by weight of solids and 18.2% as the water content. And you know, W you got it. The G also no. E is to be found. So how to get E value? To know the E value, you know again the formula gamma D equal to G gamma W by 1 plus E. So already G known, gamma W known, find out gamma D. From that you will get E value and substitute in S. So find out the dry density. Dry density is weight of the solids by volume, it is 1.65. And then substitute in the formula dry density, get the value of void ratio, and afterwards S is equal to WG by E. So here to compute the value of S, we got E indirectly by means of some formula, and we got water content by means of some other equation. And knowing G value, substitute and get the degree of saturation as 80%. A soil sample has water content 18%. The specific gravity of soil mass 1.8. Specific gravity of soil mass GM 1.8. Specific gravity of the particles 2.7. The void ratio of the soil is. So you know the mass specific gravity is gamma by gamma W. Gamma by gamma W. So gamma means GM multiplied by gamma W, and gamma W you know 10. So gamma bulk density is 18 kilonewton per meter cube. So from the mass specific gravity, you got gamma equal to 18 kilonewton per meter cube. So already you know the dry density equation, dry density equal to gamma by 1 plus W. Already we have seen the relation. So gamma by 1 plus W, you will get dry density. What is the ultimate question? Void ratio. Whenever void ratio required, you see the appropriate relation gamma d equal to g gamma w by 1 plus e. So here gamma d is to be known. Gamma d also 15.25. G gamma w everything is known. Ultimately e equal to 0.77. So here writing various known parameters and what is the parameter to be found and what is the related equation for the unknown parameter and accordingly compute the various things. Okay, I will skip some of the problems. Anyway, I will send this entire material to JNTU officials and they will keep in portal and I will skip some of the problems. You do it for homework because the entire solution also given to you because it is at the initial stage. Later, I will provide you some of the unsolved problems so that you can solve on your own. I will skip some of the problems so that you can look at later. Um, Yeah, now this is another problem. An embankment of 1000 meter cubed of earth fill with the void ratio of 0.6 is to be constructed using the excavated soil from borrow pit having void ratio. The quantity of soil to be excavated from borrow pit is. Already we have seen the last relation, all this entire basic theory is not required. Just if you understood earlier that V2 by V1 equal to 1 plus E2 by 1 plus E2, it is more than enough. So, because in both the borrow pit and also embankment, volume of the solids and also weight of the solids are same, but the total volume of the soil and also its associated void ratio is related by this. This entire theory is given for complete understanding, but once you understood this formula, it is enough. Substitute the value of E1, E2 and also V1, you will get 1150 meter cube. This is the only solution for this entire problem. This is the only solution for the entire problem. I'll show you again. You can see embankment of 1000 meter cubed V1 1000 E1 E1 0.6 E2 0.84 V2 not known. So these are the only four parameters and substitute these four parameters in the popularly known equation V2 by V1 equal to this. That's all. Sometimes I may be given some of the background theory in that to understand the total concept at appropriate places and that is not required for the examination purpose. And let us look another problem. An earthen embankment which is under construction, embankment is under construction, is having a bulk density of 16.2 kilonewton per meter cubed. 16.2 kilonewton meter cubed at water content of 8%. If the water content is to be raised 12% at the same void ratio, the quantity of water required to be added per cubic meter of soil is. So what is going to happen is when the embankment is available with the density of gamma 1 and water content 8% and volume considered as 1 cubic meter because it is given for how much quantity of water is required to be added for 1 cubic meter. 1 cubic meter. And this is the existing condition of the embankment. But for the new condition, water content is to be changed to 12%. The question is 8% water content available. If we want to increase from 8% to 12%, how much quantity of water is to be added per cubic meter of soil? That is the question. In the case 1, the dry density gamma D1, 1 means case 1, that is gamma by 1 plus W1. You know bulk density, water content and you got dry density. Dry density gamma D1. So once gamma D is known, Gamma D is known. What is gamma D? Gamma D is nothing but weight of solids by volume, or otherwise weight of solids equal to dry density multiplied by volume. Dry density 15, volume is to be considered 1 cubic meter, so 15 kilonewton. That means in 1 cubic meter of soil, so weight of the solids equal to 15 kilonewtons. Weight of solids equal to 15 kilonewtons. And what is the water content definition? Water content equal to weight of water by weight of solids. Weight of solids is now 15 kilonewtons. And water content also known 5%, 8%. Water content is known for the first case 8%. So it is 8%, it is 15 kilonewtons. So what is the weight of water in the first case? Weight of water in the first case is multiplied by these two, 1.2 kilonewtons. 1.2 kilonewton water means 120 liters of water, or 1200 1200 newtons. 1200 newtons means 120 liters of the water. That means originally in the embankment with 8% of water content, water available is 120 liters. Water available is 120 liters. Now water content changed to 12%. So according to this formula, WW1 is W1 into Ws. What is WW2? What is the water content corresponding to 12%? WW2 equal to water content into weight of the solids. Already I told you, weight of the solids remain same. There is no change in it, because for the same embankment we are increasing water content from 8% to 12%. So that's why 15 is constant. So water required for 12% of water content is 1.8 kilonewtons, which is 180 liters. So how much quantity of water is to be added? Already available water is 120. Water corresponding to 12% is 180. The water added will be 60 liters. 60 liters. So this type of problems will be there in the first chapter. And today already 1 o'clock, I am going to stop at this level, and we will provide this entire PPT to you. Go through the entire material, and if you have any doubts, there is a mechanism in the Google. You can also post it on Excel form, which is available in the YouTube, so that I can answer any type of questions, any number of questions, and I'll try to keep your knowledge very high in a particular subject. Okay, and tomorrow we will continue 15 to 30 minutes of the various problems that appears in previous GATE examinations, and also another chapter. Thank you very much. Thank you one and all for having in a continuous 2.5 lecture today. Thank you very much.